All right, so this is our first application for law of sines. Two ranger stations are on an east-west line, 110 miles apart. A forest fire is located on a bearing of north 42 degrees east from the western station at A, and a bearing of north 15 degrees east from the eastern station at B, to the nearest 10 miles. So careful, that doesn't say 10. To the nearest 10 miles. How far is the fire from the western station? All right. Well, they've already started a picture with for us, so that's great. It says that, I want to make sure. All right. So A and B are on an east-west line. All right, well, I'm going to stop talking. You guys exploit the diagram. What do we know? So we know that AB is on this east-west line, and then we have all those other bearings. So what do we know that we can fill in for our triangle?
We know that angle A would be what, 48 or 38 degrees or something like that. Whatever equals 90. What is it, 42? My brain's not working yet.
Yeah, 48 sounds good, right? Because we have this east-west line and then the due north line. We know it's going to create a 90-degree angle. So angle A has to be complementary to the 42-degree angle. Great. What else do we know?
All of angle B would be 105.
So again, we have that 90-degree with our east-west line and our due north line. So that's 90 plus the additional 15 makes 105. So then we can figure out what angle C is, knowing that all three angles have to add up to be 180 degrees. Yeah. Anybody got a calculator?
Yes, 27 degrees.
27 degrees, thanks. All right, what are we finding? How far is the fire from the western station? So we're trying to find side B here. Notice that we have a known pair. So that tells us law of sines. And then we'll use angle B and side B for the other half of our proportion. That'll be 110 over sine of 27 degrees equals B over sine of 105 degrees. And then we'll cross multiply to solve. It's B sine of 27 degrees equals 110 times sine of 105 degrees. And then we'll divide. And then we'll plug all that into our calculator and round to the nearest 10. I'm anticipating something much larger than 110 because the angle across from 110 miles is only 27 degrees and 105 degrees is much larger than that. So I'm anticipating a number quite a bit larger than 110.
234.
That's what I got too.
But then remember, we're rounding to the nearest 10, so we're just going to call that 230.
230.
Questions at all? All right, so now let's talk about our case 2 for triangles, which is going to result in the ambiguous case of the law of sines. If we're given the lengths of two sides and the angle opposite one of the sides, so this is our side-side angle case, then 0, 1, or 2 such triangles may exist. Please recall that there is no SSA congruence axiom. So if we suppose that we know the measure of some acute angle A of a triangle ABC, the length of side A and the length of side B. Now we must draw the side of length A opposite angle A. The key to determining the number of possible triangles, if any, lies primarily with the height of H and the fact that H is equal to B times sine of A. If the height, all right, I feel like I need to back up a second. I feel like I'm just reading stuff. I don't like that. All right. So in order for there to be a triangle, we have to have this side be long enough that it actually connects with the other side to make a triangle. The shortest distance between any 2 points is a straight line. So this height H would be the shortest possible length we could have for the third side so that it actually connects. So if the height here is greater than what this side here is, then that side A is never going to touch the other side to create a closed third triangle. So if H is greater than A, then no triangle exists. If the height and our side A are equal to each other, then a single right triangle is going to exist. Next, we're going to talk about what happens when that side A is larger than the height. So if the side A is larger than the height, then we might have 1 or 2 triangles, because this side A, maybe it swivels this way, maybe it swivels this way. And you'll notice it has the same length, but it's able to swing in 2 different positions. And the reason that we're open to being able to swing to 2 different positions has to do with the fact that we don't know this side. We only know side A and B. So side C, we're not sure what the length is, so it could be this little triangle, or it could be this big triangle here. This is called our ambiguous case of law of sines, just because, you know, it has options. It could be any of these things. We don't have to rely on the illustration to draw the correct conclusion in the ambiguous case. We can apply the law of sines to the values of side A, side B, and angle A, and use some basic properties of geometry and trig to determine which situation applies. So we want to keep the following facts in mind. For any angle of a triangle, sine of that angle has to be between 0 and 1. If sine equals 1, then theta equals 90 degrees, and the triangle is a right triangle. Recall that sine of theta and sine of the supplement of theta have the same sine value. And lastly, the smallest angle is always opposite the smallest side, and the largest angle across from the largest side. Hold on one sec. You going inside? Okay, put shoes on. Get some Crocs or something. Look. So let's determine the remaining sides and angles of our triangle ABC. We'll round our answer to the nearest hundredth. Oh, I know right away that I'm going to be able to do law of sines because I have a known pair. But I know now that it's going to be the ambiguous case because they only gave me one angle. There's going to be so many options for the second angle. And if you recall from trig, I always like to just assume there's two different triangles, and if there's not two different triangles, it'll present itself. Remember, rather than remembering all those facts about if B sine of A equals this, we get this many triangles. So I always just assume that there's two. All right, let's start by finding our angle A. 1 over sine of 50 is equal to 2 over sine of angle A. We'll cross multiply. Sine of A equals 2 sine of 50. So A is going to be sine inverse of 2 sine of 50. We pop that into our calculator. What do we get?
That's what I got.
Air?
Yeah.
Mhm.
Anybody else
Yeah.
get air? All right, so that means that there's going to be no triangle.
Nice.
All right, no triangle. Clearly presents itself when there's a problem. So I always just assume there's two and something will happen to tell me there isn't two otherwise. All right, let's try another one. I'm sorry, were there any questions on that at all? All right, let's try another one. We know that we're going to be using law of sines because we have a known pair. I know it's going to be the ambiguous case because we were only given one angle. So let's start by finding angle B. Six sine of 35 degrees equals 8 over sine of B. Cross multiply to solve. Divide by 6. You could simplify that 8/6 if you felt like it, but I probably wouldn't. Just plugging into my calculator anyways. OB is going to be sine inverse of this fraction here. And we'll plug in. So did we get an answer for B this time?
Mhm.
All right, so
Yeah.
what did you get for B?
49.89.
49.89. So as I said, I always like to assume that there are two triangles, and if there aren't, it'll clearly present itself. So our first option for B is whatever our calculator spits out. To get our second option for B, anybody remember what we do? It's the supplement of that B1. So our supplement's going to be what?
130.11.
130.11. All right, so those are our two options for B. In our next step, we'll figure out whether or not that second triangle is actually viable, that's actually going to happen, and we're going to use finding angle C to make that determination. We know that the three angles in the triangle have to add up to be 180 degrees. We know that A is 35 for both of the triangles, so to get like C1, we're just going to take 180 minus A minus B1. So what do we get there?
$95.11.
Great. And then we'll do the same thing with our second triangle. C2 is going to be 180 minus A minus this B2. And as long as you don't get a negative number here, you know that you have a second triangle. If you do get a negative answer for this C2, then that means that there's only one triangle, because we know that the interior angle of a triangle can't be a negative number. So do we get a negative?
No, we got positive 14.89.
There we go. So that confirms that there are two triangles, because I didn't get a negative right here. Now that we've confirmed that we have two triangles, we just need to finish solving these two separate triangles. Side C is all that's left to find. So to find C1, we're again using law of sines. So 6 over sine of 35 degrees is equal to C1 over sine of 95.11. You'll notice when I wrote this proportion, I did go back to the original known pair. Our angle B is rounded, so I didn't want to use that B pairing since it was a rounded answer. Cross multiplying. And then dividing. So C1 is going to be 6 sine of 95.11 degrees divided by sine of 35. We'll plug that into our calculator. What do we get rounded to the nearest hundredth?
I got 10.42.
Great. Be sure to double check for a unit. There wasn't a unit given on these sides this time, but always double check in case there is. Now we'll do the exact same thing to find our C2. Cross multiply and divide. And what do we get for C2?
2.69.
And there we go. Questions, anybody? All right, let's take a look at some application problems. After a windstorm, you notice that your 16-foot flagpole may be leaning, but you're not sure. From a point on the ground, 15 feet from the base of the flagpole, you find that the angle of elevation to the top is 48 degrees. Is the flagpole leaning? If so, find the acute angle to the nearest degree that the flagpole makes with the ground. Well, as always, I always want to start with a picture. So here's the ground. Here's my flagpole that might be leaning. Tells me that this flagpole is 16 feet long. From a point 15 feet on the ground, away from the base, so out here 15. The angle of elevation to the top is 48 degrees. We want to figure out if the flagpole is leaning. Suggestions on what we should do. Or even if you're not sure like exactly what to do next, even what's our bigger plan. How do we determine whether or not, how can we prove mathematically whether or not this thing is leaning?
You gotta
Good.
prove that it's not 90 degrees.
All right,
From the pole to the ground. Yeah.
all right. So this must be not equal to 90 degrees if leaning. I don't know, that's so awkward, but that's what I'm writing. All right, so basically we need to figure out what that angle measure down there is. Can we go right to finding that angle measure?
No.
And why not?
Well, because we don't have a length for the other side for the hypotenuse, we would need to find the angle on the top part. I
You
don't
got
know
it.
what to call it, but
You
yeah,
got it.
yeah.
So here's a known pair, here and here. The only other actual number we were given is this 15 on the bottom. And 15 on the bottom pairs up with this angle measure up here. So we can use law of sines to find that angle measure up there. And then once we have the green and the blue angle measures, we can figure out what that one at the bottom is, because they all have to add up to be 180 degrees. So I guess I'm just going to call this one up here, I'll just call it theta. Questions on our plan there, or what our setup's going to be? Okay, so we set up our law of sines. And then we cross multiply. We'll divide, and then we're going to need our inverse trig function. So what do we get for our theta?
I got 44.16.
Same.
It's good to
That's
me.
what I got.
All right, so that's our angle alpha, I'm sorry, our angle theta, but that's not the one we're looking for. Right, now we need our angle, I'm gonna call it alpha. And alpha is gonna be equal to 180 minus 48 minus 44.16. So what do we get then for our angle alpha?
$87.84. So it's not 90.
0.84. So our flagpole is indeed leaning, and it asked us to find the acute angle to the nearest degree that the flagpole makes with the ground. So that's going to be what, 88 degrees?
So is that considered leaning 88 degrees or is it leaning 2 degrees?
Okay, it is leaning 2 degrees, but the question is find the
Right.
acute angle that it makes with the ground.
Okay.
So yeah, I guess just the way I wrote it. Yes, it is leaning, and the acute angle with the ground is 88 degrees.
Okay.
Questions? Anybody on that one? All right, let's try another one. A pier forms an 85-degree angle with a straight shore at a distance of 100 feet from the pier. The line of sight to the tip forms a 37-degree angle. Find the length of the pier to the nearest tenth of a foot. All right, so here's the shore. I made it grass for some reason. And then we have our pier forming an 85-degree angle with the shore. At a distance of 100 feet from the pier. The line of sight to the tip forms a 37-degree angle. We want to find the length of the pier. Garrett, can I get you to mute your mic when you're not talking?
Oh yeah, sorry.
Sounds like you're having breakfast. All right. Okay, so how would we go about finding the length of the pier to the nearest tenth of the foot?
I think we would need to solve for the other angle first so that we have a pair.
All right, that sounds like a good plan so that we have a known pair because this 100 feet on the bottom is going to match up with this right here, and we can easily find that angle since I had to be 180. Oh, what's our third angle going to be?
58 degrees.
58 degrees, great. So now we have a known pair, and what we're trying to do is find the length of the pier, and that pairs up with the 37 degrees. Using law of sines, we're going to have 100 over sine of 58 degrees equals x over sine of 37 degrees. And then we cross multiply to solve. X equals 100 sine of 37 degrees over sine of 58 degrees. Just pop that in our calculator. Anybody get an answer?
70.96.
70.96. And that seems to be a reasonable answer. I'm anticipating something less than 100 since our angle of 37 is less than that angle of 58. And the directions want us to round to the nearest tenth. So we'll turn that into 70. Oh, what's that's going to bump up, right? 71.0. And our unit is feet. Questions at all? All right, we all know it comes down to a good picture in the beginning, so it's key to get that diagram down. Before we move on to law of cosines, I want to talk about finding the area of a triangle when you have a side, an angle, and a side. So for any triangle ABC, the area A is given by the following formulas. A equals 1/2 BC sine of A. And then you'll notice that we have like 3 variations of this same formula. I think of it as one formula. I cannot remember 3 formulas. So to me, they're all the same formula. If you notice, it starts off 1/2, and then it has any 2 sides, and then the angle of the side that wasn't already used. So to me, I'm always just remembering, oh, I got to use every single letter here. So if I use B and C as my sides, A has to be my angle. If I use A and B as my sides, then C has to be my angle. If I use A and C as the side, then B has to be my angle. So just make sure everything's accounted for, but I would encourage you to just remember this as one formula. Let's find the area of the triangle. We'll round to the nearest hundredth. A equals 1/2 each of the sides times sine of the other angle. And then all we have to do is plug that in our calculator. And we'll round to the nearest hundredth. Anybody got an answer?
I got 163.24.
Anybody else get that?
Yes.
All right, and then our unit's going to be square kilometers. Questions at all? All right, let's see it in an application. A real estate agent wants to find the area of a triangular lot. A surveyor takes measurements and finds that 2 sides are 52.1 meters and 21.3 meters, and the angle between them is 42.2 degrees. What is the area of the triangular lot? We want to round to the nearest hundredth. I would definitely draw a picture for this just so I could see the 2 sides and the angle across. All right, so 2 sides are 52.1. and 21.3, and then the angle between them is 42.2 degrees. Our area is going to be 1/2 times 21.3 times 52.1 times sine of 42.2 degrees. And we'll pop this in our calculator.
I got 372.71.
Sounds good to me. And our unit, square meters. Questions at all on finding area using those formulas? All right, let's move on to law of cosines. So we have our 3 formulas for law of cosines. But again, I don't remember 3 separate formulas because they all followed the same pattern. I always think of it as one side squared equals the sum of the other 2 sides squared minus 2 times those same sides times cosine of the first angle, the first side angle. I would encourage you to try to just see the pattern and not memorize 3. Law of cosines we use anytime we don't have a known pair. So let's solve the triangle. They've given us the 3 sides. We definitely don't have a known pair here, so that tells us that we need to use law of cosines. Since we're solving the triangle, we need to find the 3 angles. So we'll find the first one by using law of cosines, and it doesn't matter which one we start with. I think I'm going to start with A just because it's first. Oh, 4 squared is going to be equal to 3 squared plus 6 squared minus 2 times 3 times 6 times cosine of A. We'll do a little cleanup here. So what do we got there? 35 minus, so it's negative 19 over here. Oh no, that's 45. That's 29 over there, right? Calculators.
Yeah, it's 29.
Thanks. So A is going to be cosine inverse of 29 over 36. For angle A, that 36.34 degrees.
Yep.
Great. All right, so we found one of the angles. Now we need to find a second angle. So I think I'm just going to go right down the list and find B next. So finding B, we'll start with 3 squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of B. And we'll just do the same thing, clean it up a little bit. Isolate the cosine, inverse cosine. That negative 43. So B is going to be cosine inverse of 43 over 48.
Uh, 26.38.
Great. Now, technically, we could have used law of sines to find that second angle because we did have a known pair with the A's. But the reason I opted not to is because I didn't want to work with a rounded angle. If I went back to the original, I would be working with all given values and no rounded values. So although we could have used law of sines, I opted for this one for a more accurate answer. Lastly, we need to find angle C. How are we going to go about finding angle C? Do we need to do
Add
law of
angles.
cosines again?
No.
Couldn't you add angles A and B and subtract them from 180?
You got it. And we'll get 117.28 degrees. Questions, anybody? I feel like we use law of cosines more than law of sines when it comes to application problems, especially bearing problems. So let's take a look at this one. A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours that the sailboat is off course by 20 degrees. In part A, we want to find how far the sailboat is from Key West at this time. We want to know in part B, through what angle should the sailboat turn to correct its course? And then in part C, how much time has been added to the trip because it got off course? I'm definitely going to start with a diagram. Key West is almost due south of Naples, Florida. Not that we really need to know that to draw our diagram. All right, so it says that the distance between Naples and Key West is 150 miles. So the boat starts going from Naples to Key West, constant speed of 15 miles per hour, sails for 4 hours, and now the boat is 20 degrees off course. So 20 degrees off course. It went 15 miles an hour for 4 hours. So we know that this distance here in the red is going to be 15 times 4 is going to be 60. And then the first question says, well, how far is it now from where they're at to Key West. Okay. Suggestions?
Could you plug it in to the law of cosines and solve for a squared or?
Right, we can find our x because we have two
Yeah.
sides and an angle. So if you're given two sides and an angle or three sides, the law of cosines, what you want to use. So we can start by solving for x. So x squared is going to be equal to 150 squared plus 60 squared minus 2 times 150 times 60 times cosine of 20 degrees. Personally, if I was doing this, I would shove this whole thing in my calculator at once with like a square root over top, because obviously to find x, we're going to square root it. So I would just do square root and then that huge thing and just plug it in my calculator all at once. Let me know when somebody has an answer.
$95.84.
And our unit is miles. Great. In part B, they want us to figure out through what angle should the sailboat turn to correct its course. So we got to think about how we would do that. So right now the boat is on the red path, right? So it kind of extends out this way, and we need to figure out how it needs to turn. So we need to figure out what this angle right here is, because that would tell us how much to turn. So I think I'm gonna label this gamma, just. So how could we figure out what that angle measure is?
Would
Well,
you
we know that
find,
extended red line is like a straight line, right? And we know that two angles that are on a straight line together are equal to 180 degrees. If we were able to figure out what this angle is, then that gamma would be supplementary to it. Can we figure out what that, I guess I'll call you theta, our green theta would be?
Yeah, when you just use the law of cosines for like if you have three sides?
Sure. So we could either use law of cosines because we just found x, or we could use law of sines as well because we figured out x. It doesn't make a difference, whichever one you prefer to use. So let's do law of cosines since that's what Jordan suggested. Finding that angle theta there. We'll start with 150 degrees squared equals 60 squared plus 95.84 squared minus 2 times 60 times 95.84 times cosine of theta here. So I can hear the calculators going, which is great, but we're going to get rounded and rounded and rounded answers. You either need to keep all the decimal places or just try to do some algebraic manipulation so you can plug it all in your calculator at once. If we do some rearranging, we're going to get that theta is equal to cosine inverse of 150 squared minus 60 squared minus 95.84 squared divided by -2 times 60 times 95.84. Personally, I feel like I would just plug that in my calculator. Be sure that you have your numerator and denominator in parentheses if you are going to choose to just plug it all in your calculator at once. If you're not comfortable with that, that's fine. You can do the cleanup. But just be careful about how much you're rounding.
For theta, I got 32.36.
32.36. All right, so then our gamma is going to be the supplement to that. So if we do 180 degrees minus that theta, the angle through which the boat needs to turn, 147.64 degrees.
When I plugged it into the computer, I got 147.639.
Okay, so round 39 to 4.
I
Because
was
it says
just wondering,
hundredth.
I was wondering how she got 32. Never mind, I see it now.
Wait, what?
Yeah, when I plugged inverse cosine in, it gave me 147.
This right here.
Yeah.
That's what I got too.
I don't know.
Let me make sure I didn't write it down wrong. All right, let me double check it.
Well, weren't we solving for theta though?
Yeah, but the angle in which we would have to turn would be the supplement to that.
Oh, okay. I see, but
You're saying when you did inverse cosine of that gross fraction, you got the 147.
yeah.
All right, now I'm going to double check everything I have written.
Now I used the law of sines and I got 32.36.
Did you make sure to put the parenthesis? I know that 32.36 is the correct answer for theta. Did you make sure to put the extra parentheses when you did that inverse cosine?
Yeah. It's weird.
Yeah, I'm going to think about that in the back of my brain while we keep going. I don't know why I would have done that. That's great. That sounds crazy. I'm getting my calculator.
My calculator did the same thing. I don't know if I plugged it in wrong or what went on.
But I did law of sines and I got the 32.36, but then I did the way that you guys did it and I got the 147.
Huh.
See, and that It doesn't make sense to me because cosine inverse is defined in quadrants 1 and 2. So we should have been able to get either of those angles. All right, I'm gonna keep thinking about it while you guys do the next part while I'm plugging this into my calculator. So we want to know how much time has been added to the trip because of this getting off course. So how would we figure that out? How would we figure out how much extra time it took?
Can you just set like a ratio up?
Like what did you have in mind?
Like maybe take the total mileage that they did versus total mileage of a straight line and set them equal to each other and then solve for X.
Where X equals what?
So
Or represents what?
maybe I would do 10 hours over 150 miles, right? Is that how far they went? And
They
yeah,
did go 150 miles, but where'd the 10 come from? You just pluck it out of the air?
no, if they're going 15 miles per hour and the original distance is 150, wouldn't that be 10 miles per hour?
Oh, I see what you're saying.
And then do 60 plus 95.84, and then set it equal to X over 155.84. Wouldn't that give you?
Okay, hold on. Sorry, I was like half listening because I was popping it in my calculator. So yeah, I think that would work. I probably would have done it just, a little bit more direct, that we now know that they traveled 60 plus 95.84 miles. So that'll give us our total distance. And all we need to do is divide by that 15 miles per hour to get the extra time. So you're not wrong, you're just doing it a little bit longer way, I think. So the extra miles is 5.84. And since distance equals rate times time, it follows that time is equal to distance divided by rate. So to get the time, I'm going to take the extra distance and divide it by its rate of 15. Man, I'm getting that 147 as well when I do law of cosines. That's bothering me. I'm going to report back on Monday about that. Oh my goodness. Oh, I already figured it all out. Okay. All right, I'll come back to that. So what do we get for the extra time?
Uh, 0.39, like hours longer or whatever.
All right, so 0.39 hours. If we wanted to convert that to minutes, how could we do that? Because nobody says, oh, it took me 0.39 hours.
Yeah.
Do you multiply it by 60?
You got it. So if we multiplied that by 60, how many minutes are we talking?
23 or something like that.
Okay, so what is it?
Well, it's
23.4?
23. Yeah.
Okay. All right. I know I didn't ask for the minutes. All right, so I figured out the other dilemma. Oh my goodness. I feel like I'm gonna take it off. Excited. Oh, turns out the people who did law of cosines have the right answer. Oh great, I just erased it now. All right, so theta is equal to 147.63. And I actually like law of cosines a little bit better than law of sines because it's always going to give you for sure the right answer. I feel like I did this wrong on my video. I'm gonna have to go back and check it because I think I used law of sines. All right, so theta is equal to 147.64. And to get that gamma, we are going to find the supplement. So the reason that the people who used law of sines didn't get the correct answer, it wasn't that you didn't get the correct answer, you just didn't finish the problem. See, it was ambiguous case of law of sines. Because we have only one angle and two sides. So you would have gotten your first angle, which would have been that 32.36 degrees. But then to get your second option for that angle theta, you would have done the supplement to it. And it is the supplement angle that we would actually want. Now, I know there's no proof by picture. There isn't. But if you look at our picture, doesn't it look like our theta is an obtuse angle while our gamma is an acute angle? Especially, in fact, my drawing, if we were to draw it more accurately with our links for our red and our green line, it would be even more like, you know, this is 150, and then this is 60. Oh, now I don't like any of the stuff you say. Okay. But that's why we're getting the two different answers. It has to do with the ambiguous case of the law of sines. But I think the law of cosines is the right one. So if we went 60 this way, and 90 back this way, all right, I'm going to think about it more. We're going to talk about it again on Monday. But I know that it's the ambiguous case is why we're getting the two different answers. And I believe that this law of cosine answer is the right answer because law of cosine, there's no ambiguity to it. It always just spits out the correct answer. Is everybody okay with that, with me getting back to you on Monday about that, why we have that discrepancy? I want to think about it a little bit more. Oh my goodness. All right, well, I'm already like 10 minutes over. Why don't we just stop there and we'll finish up law of cosines on Monday. And then I think we start into vector, no, we start into polar coordinates. So. Anybody have any questions on anything? No? Okay. All right, well, have a wonderful weekend. I encourage you to be working on your My Math Lab, working on your quiz. Right, not due quite yet. Well, Jose, yours is due on Sunday at midnight, like always, but.
Yeah.
Hey, Samantha, just hold tight. I'm almost wrapping up here. I'll jump right to you.
That quiz, which quiz is it?
What does it say? Take home quiz chapter 6, posted in D2L.
Okay.
But we got to get through polar and vector and everything like that. So it's going to be, I would say, like a week. What does our calendar look like?
I wanted to ask you, with those take-home quizzes, do you just want us to take pictures of our work and send them to you?
Well, you know, all right, hold on. Let me think for 1 second. All right, so here's our revised calendar. Yeah, we're already super ahead of schedule because we're not even supposed to start law of cosines till Monday. Okay. Chapter 5 quiz. Okay, but you guys did not hand in your Chapter 5 quiz yet. Correct?
No, we haven't.
All right, so Chapter 5 quiz, let's get it to the Dropbox by the end of the weekend. All right, and everybody's comfortable with getting it into the Dropbox? Oh, geez, I stopped sharing my screen. I'm like showing you all this stuff and I'm not even sharing my screen anymore. Sorry. All right, so our take-home quiz for Chapter 5, we'll make it due Sunday at midnight.
Hey, I hate to interrupt, but I got another class coming
Yeah.
up, so I gotta go.
Okay.
Thank
yeah,
you. See ya.
No problem. All right, so have that in Sunday at midnight, and I imagine the My Math Lab homework's due soon. I think I saw an announcement there. Yep, that's Sunday at midnight as well. That sound good? All right, Olivia, what was your question? I'm sorry.
With submitting those quizzes, do you want us to take pictures of our work on the quiz and send them to you? Okay.
So I imagine, I mean, if you have a printer that you're just printing out the quiz and then you're going to do it like normal, and then you're just going to take a picture or scan it or whatever, and then just upload those files to the Dropbox.
Okay.
And if you don't have a printer, then you can just write it on a piece of paper, and that's fine with me. But you don't have to write out the full directions and all that kind of stuff. You can just fill out, you know, write what you need to, and then send it to me. And then I have this cool D2L Grader app where I can just pull it up, and I'm going to use my tablet. I'm going to write right on it, just like I would if I was writing on your paper quiz. And then I will post that back to the Dropbox, and you'll be able to see everything, all my handwritten comments, just like normal.
That's nice.
Just
That way
don't
we
need
can have the
to,
feedback.
you know, touch each other in any way. So, all right. Anybody else? Questions on how to do any of that? All right. Don't get stressed out if it's not working or whatever. Or if you have issues, just relax. You know it's going to be okay. Feel free to send me an email if you're having any trouble with anything. And I'm going to finally get around to looking at the results of the office hour surveys, because I just sent it out to all 100-some people. So I'm going to sift through that and figure out what times. So I'm hoping, I don't know what you guys answered, but I'm hoping that maybe this class would just like some time on Fridays after class, maybe, or in that gap time. We'll see what everybody said.
Yeah.
Okay.
Okay.
Awesome.
Thank you
Dylan,
very
if you
much.
did not have the opportunity to take that quiz because you were having technology issues, it's still open if you want to take that survey real quick and give me feedback on times that you would like office hours.
Okay, I can do that.
Okay. It's posted in the announcements, and I sent it out in an email.
All right.
Anybody else? Anything? All right. Have a wonderful weekend.
You too.
All right. Bye.